Good afternoon. My name is Mark Tabladio, and thanks everyone for coming to this last session of TechEd. I hope it's been a great conference for you. I just enjoyed being here and meeting so many people and seeing so many great sessions. And you're here today for Data Mining 2012 with Microsoft Excel 2010 and PowerPivot. And this is exciting technology. How many of you have tried using it before? Anyone tried using this technology? Okay, so some people have tried it. Today we're going to talk about SQL Server 2012 specifically, and you'll see that as we get into the presentation. So here's my information. Of course, these slides will be available later, and these presentations are being recorded. I made a landing page, which I'll show you later on marktab.net, to show you some more information about me, and I'll be giving you more of that information as we go on. I'm from Atlanta, Georgia, and this is my first time in Amsterdam. I have been to Europe before for different business reasons, and I have enjoyed coming here to this trip and visiting Amsterdam for the first time. I'm part of the Microsoft MVP program and have been contributing to the communities, mostly in the U.S. Here's the outline for today. We'll talk about the fundamentals of data mining and then do a demonstration. It's going to be a little bit more demonstration heavy, and then talk about some resources. I'm a big believer in education. I continue to learn more about this topic myself, and this is also an active area of research, so something that we all need to learn more about in a professional context. So here's some of the fundamentals. First of all, as far as definitions, I both use the phrase data mining and also machine learning. How many of you have heard the phrase machine learning or have used that phrase, machine learning? Okay, so some people have. It seems like now if you want a graduate degree in computer science that you can't get through that process without taking a class in algorithms or machine learning these days. So it's increasingly becoming important in schools. Functionally, they do mean the same thing, looking for patterns in data. But as applied to practical problems, the word or the phrase data mining means informing actionable decisions. And that's always going to be the goal. I like that as a general goal for business intelligence, to inform actionable decisions. I like to say that the goal of BI is not to be building cubes or data warehouses or data mining models, but actually to help people make decisions. And as I've worked with clients in many industries, that's the focus that I like to frame our goals on. Machine learning has a slightly different goal, and that is to determine the best performing algorithm. That might be a subset toward informing actionable decisions, but that's not the same type of thing. So often people that come out of the machine learning mentality will have an idea of which algorithm is their favorite or which one they think is the best. I like to compare it to the knife, the spoon, and the fork. And if you only had to pick one to eat with, which one would you eat with? Okay? And then some people said, well, you know, I actually prefer to eat with chopsticks. Or someone might say, well, no, actually, I prefer the spork. You know the spork? Because you can have your soup and your salad with one instrument. So, again, machine learning is about maybe determining the best one under certain conditions. Data mining is not about choosing among those, but trying to figure out how to use them all together. SQL Server data mining is a service, and that's the first thing to emphasize. There are some other products out there that do data mining, and they are basically applications. To say that it's a service means that it's ready for the enterprise environment. And it's also codable. It's codable, and it's a service. It works on SQL Server Analysis Services. We're going to be talking today about the Excel interface to that technology. And don't let it confuse you that this is all happening in Excel, because it does require SQL Server to be behind it. Which edition of SQL Server is either the Business Intelligence edition or the Enterprise edition of SQL Server? I'm using the Enterprise edition today. And as I say here, there's multiple interfaces. There's Excel. There's also what's now SQL Server Data Tools. That's formerly was called BIDS. There's SQL Server Management Studio, and there's PowerShell. And we're not going to talk about the other interfaces. We're just going to focus on Excel. I know there's other things that you can do with this service, and those would be for higher level presentations. The level of this presentation will be level 200. Data mining add-in for Excel was updated for the SQL Server 2012. Someone did report to me that they were not able to make this work with 2008 behind the scenes. So if you are wanting to use this new add-in, you will have to use SQL Server 12. There are other add-ins that are also free. One was targeted at 2005. One was targeted at 2008. How many are using 08 in production? SQL Server 2008. How about 05? 05, anyone? 05? How about SQL Server 2000? Anyone still using 2000? Okay, you got guts. So actually, there should be a presentation how to use SQL Server 2000 in 2012. That's just what I'm saying. You're not alone. And the data mining technology was introduced with SQL Server 2000, but the full suite of algorithms was introduced in 2005. So starting with 05 and going forward is where you see the majority of the technology. The new add-in works with either 32 or 64-bit Office. I'm going to be using the 64-bit add-in today. And of course, 64-bit will allow you to use more memory for the application. It does require analysis services. And here I have on the bottom enterprise or business intelligence, or you can also run developer edition if you're evaluating the technology. PowerPivot for Excel. How many of you use PowerPivot for Excel? Yes? Okay. So we'll go through that and we'll see some features. It has been a topic that I've been getting more questions on. Part of the jobs of the speakers to answer questions in the Technical Learning Center, and increasingly people are interested in PowerPivot and PowerView. Those are some of the curious technologies now in the 2012 cycle. This technology is one of the features is that it stores this information in Excel workbooks. It leverages memory for fast processing. It loads large data sets, and especially in the 64-bit edition. Provides analytics through the DAX language, and it leverages multi-core processors. And I would recommend later, if you have not, or even if you have seen PowerPivot, you can look at this link, and there's some videos online that you can see about what PowerPivot can do. And they've done a great job in releasing more videos. Microsoft generally has a lot of videos on a lot of topics. You'll find videos on PowerPivot in this area, plus also generally you'll find a lot of different videos in Channel 9, which is where they will put the TechEd videos. Demonstration data for today will be Contosa Retail. There's a demo data set. You can download this data set yourself, so you can replicate what I'm doing. And then also I'm going to plug the Windows Azure Marketplace. I'm going to show later in PowerPivot how you can get data from Windows Azure Marketplace, and it is a cloud-based service. It is what Microsoft will be promoting to share data, and especially for other technologies like data quality services. So that might be something you want to look at later. All right, now this slide will show you all the code that you need for this level 200 presentation. Okay, so that's it. So this is not going to require you to read or understand code. However, I will be talking about some concepts about business intelligence and analytics and just the way of thinking about data that probably will test the limit of your knowledge about how numbers work, and also impress on you some of my philosophies in working with data. I've enjoyed working with data. Like I said, I've worked with clients in different types of industries: insurance, government, utilities, and retail, and just different types of projects over time. And in addition, I've also had a role part-time teaching at University of Phoenix, where I've been working with students on their dissertations. And I actually have an oral defense coming up once I get back to Atlanta for my 6th student now that I've graduated through the doctorate program. So I think going through research process is important. It's also important as I would like all of us to approach data mining as a science activity. Okay, so here's the question. How many of you have a degree that has the word science in it, such as computer science? How many of you have a degree that has the word science? Okay, so same group, how many of you think of yourself as a scientist? Okay, so see, this is an interesting thing. Now, I feel that we do science, but there's something about claiming the title scientist, even if you have science in the name of a degree, that somehow you don't feel like doing it. I would like us to feel more comfortable with science, or at least practicing it professionally, especially if you've had a degree with that title in it. All right, we're going to have two demos, or two demo sections, I would describe it. One's we're going to do the analysis tab, and then later we're going to do the data mining tab. Now, back for the first section, your analysis tab, we're going to focus on specific data mining models. And later on, we're going to do racing. We're going to race some algorithms. So that's what you'll see in the second section. So as we go to this first section, I'll turn the projector on. First, I want to go just straight to Excel. So we're in Excel now. Okay, it doesn't show it. Okay. Oh, sorry. Is that good? All right. There's always a delay, and also I have to push that button and that button. All right, so here we are in Excel. On the top here, you see the data mining add-in will come to the top. So I'll show you right there. It's where the data mining add-in is coming to the top. Whoops. Okay. Make sure that's on draw. And so there's a data mining add-in. Now you notice I have on my computer a lot of other add-ins that have collected over time, but we're just focusing on the data mining add-in. First thing I'm going to do is go to PowerPivot. Now there's a PowerPivot add-in that is also separately installed. So there's a PowerPivot add-in and a data mining add-in. Data mining add-in is free. The PowerPivot add-in is free. You have to install both of them, and this is on top of Office 2010. So PowerPivot window. So I click that button there. I go to a separate window, and here's where I was talking about the Azure Data Market. This is where you can get other data sets. You would just have to have an internet connection for that and a subscription. But you can also get other data in there. And then I'm going to go, in this case, from database, from SQL Server, localhost. And I always like to test connection. And go to Contosa Retail. Next. All right, so now we're going to be looking at a list of tables that is in my Contosa Retail data warehouse. One thing that I'm going to do in this first study is we're going to predict sales amount. That's going to be the goal. Predict sales amount. That's the goal of our investigation. So I'm going to choose sales and click Select Related Tables. When I click Select Related Tables, it gives me other tables that are directly related to that table. And it just, it's a convenience feature. If you don't like it, you can just click those on or off or pick other tables. And for any of these, you could preview or filter the tables. I'm just going to take it as is. So it's reading in the tables. First few tables had, between 4 or just under 3,000 rows. And then this last table, fact sales, I picked this table because this goes beyond the normal amount of rows that you would have in Excel. So this is over 3 million rows. Okay, close. So now on the record, if I look at the lower left hand of the screen, I can see how many observations are in each of these tables. And the fact sales table there is 3.4 million. So there's 3.4 million observations in that table. Going back to the regular sheet, I could save this right now as a workbook, and I'm just going to continue to work. But that data would be saved. So it's read from a SQL Server. It's now in Excel, and it's now available for data mining. To be able to pick it, we have to go first to this pivot table. So I'm on the PowerPivot tab. I'm going to go Pivot Table, Flatten Pivot Table. The reason I'm going to do a Flatten Pivot Table is normally when it does make a pivot table, it'll have these intermediate subtotal rows that it produces just automatically. And we don't want any of those rows for data mining. We just want to have the raw data. So I'm going to do Existing Worksheet. Click OK. So there's your pivot table. Now, There were some other questions I wanted to ask. But let's go ahead and go forward here on where we are. So I'm going to go to the tables, fact sales table, and do sales amount. Drag it into values. So right now, what I just did summarized those 3.4 million records. And of course, it does work pretty fast because it's all in memory. And so that's what, that's how this technology works. Now, of all the, going back to this PowerPivot window, there's a way you can look these in terms of a diagram. Let's see. All right, so here's our diagram. So we have the fact sales, and we have all these other dimensions that came in as a result of the import. Dim product, dim promotion, dim date, dim currency, dim store, dim channel. If I'm going to predict future fact sales, which dimension is the most important? The date. Okay, so dimension date. You need to have the date to be able to predict the future. The dimension date is just a dimension that has dates in it, and of course the dates here started in 2005. Let's see. One thing I noticed too when I read this in is that for some reason they're not sorted in any particular order. So anyway, they start in 2005 and it goes all the way to 2011. That fact will be important later. I'm going to talk about that. Going back to the original sheet, so I'm on that sheet here. So I got the sales total. Now I'm going to also drag on sales again, but this time I'm going to summarize it by change the summarization. Let's see, it lets me click it. Not letting me click. Oh, okay. First I have to do the date. So calendar month. Okay, so I put calendar month on the left side, and they have sum, and I have sum again, but I'm going to change the sum to something else. Come on, change. Oh, this needs to be removed. Let's see. Let's do that again. Sales amount. Okay. Somehow something got funky and put something into the column labels thing, and that was messing this thing up. Whoa. It's not letting me do this. So, yeah, I don't know why it's not letting me make this into a count. Sum the values. Okay. Edit measure. I'm going to say, wait, hex. Here I was edit measure. Oh yeah, okay, count. All right, that fixed it. Okay. Yeah, somehow the navigation's not working. But anyway, I'm going to do that. And measure, and I'm going to do average. All right, so I have the count and I have the average. So the average times the count is what? The sum, right? Okay, so the average times the count. So what this shows here is a 2007-01, this sum of sales, then there's an average of sales, and then there's a count of sales. So that's what the columns are showing. And I'm going to go over here to select. There's a select button for the table. You can select the entire pivot table, copy it, and then I'm going to go to the next sheet. I'm going to paste it, just the values. Then once I paste the values, then I'm going to format it as a table. Now I have it as a table. Once I have it as a table, a new tab pops up called Analyze. And this is the Analyze tab for data mining. So let's zoom in here, and let's look at the Analyze tab. Analyze key influencers. We're not going to look at all of them. Analyze key influencers is naive Bayes. Detect categories is clustering. Fill from example is logistic regression. Forecast is time series. Highlight exception is clustering. Then there's a scenario analysis. There's two options in there, and they're both logistic regression. Prediction calculators, logistic regression, and shopping basket analysis is association rules. So those are some of the algorithms, or not all of them, but what happened is Microsoft decided to make this tab for single-shot data mining. So this is the recommended first tab. If you just want to do data mining or get started, you want to use the Analyze tab. You just press one of these buttons, you can make a model, and then be done with it. So that's what I'm going to do. I'm going to do forecasting. And I'm going to forecast sum, average, and count into the future. And you notice on the bottom, it's number of time units of forecast is 5. The timestamp is going to be calendar month. Press run. The most important thing on the dates is that the dates are equally spaced. So if you had just January and then you had nothing for February and then March or whatever, and then you had some missing months, you got to make sure you add additional space or just have values that reflect 0 or something in there. Okay, so it does come up with a result here, and the result shows as a chart. Now the interesting thing about this chart is, and first I'm going to show you how it's broken, and then I'll show you how I know it's broken. So here's that light blue, that's the area that it forecasts in the future, and that's for sum of sales amount. Now average and count compared to sum are a much lower number. So they're supposed to be down here in the bottom, at least as a line, but they don't show up as anything. So they do show, though, if you went to the other tab, Data Mining, Browse, and I'm going to browse the model that I just made, and that was the one right here, Table 1, 1832. So if I browse that one I just made, go next, and there it shows. Now this is a different view. This view starts at 0 on the left, and then what it does is it shows you what percentage increase each number has into the future based on 0, right? So it's kind of the relative view. And there's a button here up on the upper left. I'm going to zoom in on that button, that ABS button. That ABS toggles between the absolute value and then the relative value. So it toggles between the two. But if you notice on this one, the absolute value, this is the way the other chart should have shown, because on the bottom here you can see that there's two colored lines. It does show, and I don't know if it shows on the screen, but you can see that there's an attempt to draw a line, all right, even with those numbers off. So that's the numbers. They're predicted into the future. Going back to the first page, what happens on the original chart, this is the chart I had, it'll put the numbers there on the bottom of what those predictions are into the future. But it doesn't extend the dates. So the dates here on the left were left alone, but then it'll show 5 periods into the future. Okay, so we have sum, we have average, we have count. Okay, now I'm going to do some calculations. I'm going to do calculated sum, and then I'm going to do calculated average, and a calculated count. All right, this is one of those math puzzles, and I know people love puzzles, right? So, sum, what is the sum? That's going to be equal to the average times the count, right? What is the average? That's going to be equal to the sum divided by the count. That's the average. And then the count, that's going to be the sum divided by the average. Okay. So, yeah, they're the same up there. In fact, it looks the same, all right, until you get down to the bottom. So here's where the trick is. So if you see on the right, okay, so here's where the math puzzle is, at the bottom. So I had average and I had count. These are predictions for average and predictions for count. If I multiply those two predictions together, I will get numbers, but those numbers will not be equal to the numbers that I had here on the left, the sum of sales amount. And now, to help you understand this puzzle, one thing that this technology will do is called cross-prediction. And so what is cross-prediction? So not only will it predict based on the current column, but it'll predict on all the columns that you present to the algorithm. So when I ran that time series analysis, it's not just predicting for one column, it's predicting for all three and together. That in itself opens up possibilities of how you might use this technology. And I'll give you some ideas as we get to the end of this section. But first of all, okay, I'm going to give you a choice. So the choice is, if you were going to predict calculated sum, and you're here on the screen, choice 1 will be multiplying those two together. Choice 2 is going to be going just with what it comes off the sum, and choice 3 will be it depends. Okay, so how many would choose the first one, calculated sum, if you were going to predict into the future? Anyone? Okay. How many would choose choice 2, the sum right there, predicting in the future? 1. Okay. How many would say it depends? Okay, that's an easy way of saying I don't know, right? So, okay, so in general, I would recommend choosing the single prediction if you had a choice. In this case, and now let's say this is saying the prediction's already done and you don't have a chance to redo it. But if it's already done and somebody just gives you these numbers, it's actually better to choose the single prediction because there's now two sources of error in the other prediction. So that would be the answer for that. Now the it depends would be when you look at the numbers and you actually plot them out and you might see that you prefer one way over the other. That might be when you're just empirically determining what you think is the better solution. And then again, this is what I would call a good application to science. You know, when I have my students do an oral defense, they have to not only present the results, but why they think that's the better answer. And now this might test your brain because you think, well, if I'm dealing with numbers, there should be only one answer. But the fact is, there might be different answers for doing predictions depending on what your assumptions were. And that's okay. All right? So I'm giving you permission to have different results. So if you were working on a team and both of you were doing some sort of time series prediction and you don't come up with exactly the same numbers, you don't have to worry about it. It's not a calculation, it's an estimation. But it's not just completely random estimation. I mean, it's an estimation within bounds. What bounds? So if I look at, again, the graph, and the one we can clearly see here is the total. So if I look at the total graph and then how it projects off into the future, it's not like, you know, going to project off into this upper area down here. It's going to be somewhere in that range. So that's a reasonable prediction. You know, technically, there's a lot of different values you could predict there, but it is bounded. Yes. So the question was. Correct. It already combines two elements. Right. And okay, I'm going to address that factor. Whether or not more attributes lead to a better prediction, right? Is that the question? Do more attributes lead to a better prediction? Okay, and I'm going to choose it depends, which I'll talk about that in a second. But thanks for asking that. All right, I'm going to go back here and show you something on the screen. Now, this is back to the data mining tab. There is a trace option here, and the trace option will show you the code that was run. So there's code behind this technology. It created a mining structure, and then into the structure it made time series using Microsoft time series, and then after that it did some other functions. Basically, again, this is 200. I'm not going to tell you what this code says or means. The most important thing in looking at this code is that you can see the code. Okay, this is a code generator. And as we know, I like to write code, but I also like it when I have some automated tools that help me write code, and especially when the syntax is complex. So anytime that that's true, that's a good thing. Yes? Which forecasting method is being used? Okay, because I am using Enterprise Edition, I have a choice between two. One is called ARTXP, and that's Microsoft's own technology, and the other one's ARIMA. And ARTXP is good for short-term predictions. And there's a Microsoft paper that shows what that algorithm is and how they came to that conclusion. That's an advanced paper. The ARIMA is used for long-term. And the Enterprise Edition is the only one that has all the full features of blending those two models together. So because I am using the Enterprise Edition, that is what I get from that technology. If I press Document Model, I'm going to document the one I just made, which is that one. Complete information. I'm going to show you what it makes. It makes documentation. It will show some things here, such as what the input columns were. And then for each of the algorithms that are in Microsoft technology, there's algorithm parameters that you can set. Now, today I'm not going to talk about changing those parameters, but I'm going to tell you that they do exist and that you can document what they were. What they were. We're looking past tense. Future tense is a more advanced presentation of how to set parameters. But the forecasting method here with mixed, this also answers your question. So what it does is it mixes. So what it does, it blends it. So the short term, it would use ARTXP, and then the long term, it would use ARIMA. In the equation, so that's the browse. Let's see. I want to say something else on the browse. Yes, so I'm going to go back to the browse. I will show that it does show you some deviation bars. Again, this is for time series. It shows deviation bars. And on the model here, it shows an indication in the bottom right there, that ARIMA equation. Okay, so it shows some equations of how it's getting to its values. Let's see, one of these showed, let's see, go here. So if I go down here in the bottom, what it's showing is that the count was based on the average. And this is, again, what I was talking about with cross prediction. It will base not just on its own column, but on another column. All right, now I'm going to give you some ideas of what you might want to do with this technology. Does anyone invest in mutual funds? Mutual funds. Yes? Nobody's investing in mutual funds? You just buy stock, right? Microsoft? Okay. Anyway, so one thing you could do with this technology, you could have each column be a different mutual fund. And then you could ask yourself, is there any evidence of cross prediction on the funds that you choose to put in the model? And you might do better. Maybe a technology stock might have some correlation with a utility stock, or you have some seasonal trending. I don't know. I'm just saying that that's something you could do. Another thing you can do fantasy sports. So you can have predictions of either players or teams and how their performance was in different months, and try to ask yourself, again, doing the cross prediction thing. Now, one thing with fantasy sports is if you have one player's numbers here and the second player in the second column, the problem with doing that type of problems, they weren't playing the same game. They were playing in different games. Okay, so, but still, you can just analyze the data and see if that does make any sense. Another study you could do is you could do a medical study. So you can have time series data with medical indicators, such as blood pressure, such as temperature, and those types of things. And again, now, does anyone have an idea of how many variables or attributes could be in one model? Shout out a number. I did one with 3. Anybody have an idea? Thousands is getting close. Okay, so the number is 2 to the 31 minus 1. And pragmatically, someone from the analysis services team told me the practical limit is 64,000. So, obviously that's a lot larger than, what you might want to do maybe in terms of mutual funds or player analysis. There's a lot of attributes, and I'm just telling you the technology behind the scenes is enterprise ready. Even if you don't want to do just 1 or 2 columns, it's great. If you had a really small problem, if you're just doing 1 column, let's say 5 values, and you were trying to predict a future value, you could do that with your eyes. You don't have to use this type of technology for that. All right? You could come up with a pretty good estimation of where you think the number is going to go next. But if I gave you just the problem that I just showed you there with the cross prediction and then asked you to do it, it's a much harder problem and to try to find the patterns that would come out of this technology. So that's what the advantage is here. One thing that's important in the type of data, now I'm going to address that question in a second about the number of attributes because I have a special graph for that. But one thing I want to say right now is that to be able to do a prediction, you have to have predictable information. I know that sounds basic, but this is the issue that challenges managers in actual businesses. Now, there was a man who named W. Edwards Deming, and he became, to me, sort of the guru of quality. He's had more influence. How many of you have heard who Deming is? Anyone heard the name Deming? Okay, Deming is worth looking up because if you talked about people who've had impact in the area we call today business intelligence, one of the top 10 people definitely has to be Deming. He's someone who showed the Japanese after World War II how to use statistics for statistical process control and how to do this type of time series prediction. And one of the things that he would tell companies is that management is prediction. So to be able to do management, your job is essentially prediction, predicting the future. To have that ability requires to have some sort of stability in the environment. And that's a prerequisite. So one of the things, even when you're setting up this problem, is deciding what data should go into the prediction. So here we had our raw data. I just used the whole thing. Maybe when you do the problem, you might decide, well, it's unfair to do data. Now this, it's about 3 years worth of data. Maybe something happened 2 years ago that makes this series not the same before that. So you might want to start only 2 years back instead of using the whole thing. That might be a reason to filter it. And there might be other filters. Okay, so that is the output from that. So that's just one thing. I did one thing out of this data, and that was to show some future values. I'm going to close that workbook, and I'm going to start a new one. Don't save. Okay, let me see if this one's okay for this. I think this one will be okay for this. Okay, we're going to start a new one, and I think I'm going to base it off this one. This one is got a longer table in it. It's 12 million rows, so I just went ahead and pre-read it into. Now, the goal of this second study is we're going to predict marriage. We're going to predict marriage. So I'm going again to PowerPivot, going back to the pivot window. I'm going to use one table only, which is this customer table. Okay, so it's got some names. Look at this information that this company had. Now, this is a retail company. Okay, so I know. They have people's birth dates, retail company. And they have marital status, and they have other information. Email address, yearly income, total children, education, occupation. So those are some of the variables that this data has. One thing that I do want to use, I'm going to show you an example here of DAX, is the birth date. Now remember earlier I said, I talked about that date dimension. Does anyone remember what year it started? I just showed it, I know. 2005? Okay, so it started in 2005 and went to 11. These birth dates are outside that range. Okay, so I can't use the date dimension for that. What I can do is I can go to the end here and I can write a DAX formula. Dink. And if you don't know what they are, okay, so DAX formula, I'm on the PowerPivot window. One thing, I always like this little guy, f of x, function based on x. And I click it, And you can see all the formulas for different things. If I go to date and time, then it'll show you exactly what the different choices are. Year of date. So year is what I'm going to pick. Okay, and then I'm going to pick the birth date. Go back to where that was, birth date. Press enter. Okay, and it comes up with just a default name. I'm going to call it birth date year. Okay. I'm going to use that birth date year as part of the prediction. So my theory is birth date year has something to do with whether or not someone's married in this data set. PowerPivot, pivot table window, existing worksheet. Okay, whoops, I did it wrong. I'm going to do this again. Sorry. Flatten pivot table, existing worksheet. Okay, good. All right. And as my input dates, all right, now first thing is I'm going to put birth date year, okay, which is what I had. That's a calculated field that came off of the DAX. And gender, then I'm going to do yearly income. And total children, number of children at home, education, okay, occupation. By the way, the order doesn't matter on the bottom because what will happen is it just won't matter. The ordering would either be in that order or it'll reorder by alphabetical. And then number of cars owned. Okay. And I'm going to do customer type as a filter. All right, so I'm going to show you all something here. Customer type as a filter. It doesn't let me go in there. Okay, I'll just hold it there. What they did in the Contosa retail database on the customer dimension, they put companies and people together. So now I'm going to ask you a question. So the question is this. Here's your three choices. So choice A is you like the customers combined with company and people. Choice B is you prefer to see them separate. Choice C is it depends. So choice A, how many pick they're okay with Contosa retail design, mixing them together? Okay, choice B, separate them out. Separate them out. Okay, choice C, it depends. Okay, a few people say it depends. One of the reasons to separate it would be for users. Now you see that people say, well, what's easier for users? And it depends, right? So that would be it depends on the user. Do the users want to see all the companies in this same dimension so that when they make these pivot tables or maybe they're using PowerView that they drag on elements and they're expecting to see companies in the list, or is it just people? In our case, we just care about the people for this prediction. So I'm going to change it. So now only the people are on here on the bottom. And then the second thing I'm going to do is go to the Design tab and do not show subtotals. So I'll take the subtotals out. Those subtotals were those intermediate blank rows that were in the middle. Then remember what I did before. I went to Options. I did Select Entire Pivot Table. I'm going to copy. I'm going to go to a new sheet, paste. Okay, and then this bottom area I'm going to format as table. Boom, it'll pick the Table has headers, and there you go. So those are the headers. So these are all the variables, and those are the headers. Now think about what I did. This is actually coming off a pivot table we originally had. If I go to the other screen, see how many, and this will just be the raw number of customers with the companies, but the people dominate the whole list. So there's fewer. Most of these are people. So right now there's 18,000. So it's 18,000 now is represented by this list. And this list, though, is only the number of unique combinations. So, there's somebody who was born in 1910. I don't think there's going to be a lot of those combinations out there. But if you go down the list to the bottom, it's about 4,000 rows, and the last birth date year that's in this database is 1980. So 1980 is the end of this birth date year for this population. So for this marriage prediction, I'm going to do a prediction calculator. I'm going to predict. Wait, did I draw my marriage on here? No. Okay. Sorry. Didn't draw marriage on there. That's the most important one. Okay, so I've got to do this again. I'm going to have to go to design, subtotals, turn the subtotals off. Okay. Options, select, entire pivot table, copy. Okay, so there's marital status. All right, prediction calculator, and target marital status, male. M is married. M is married. Now, because there's only two categories, actually it doesn't matter if you pick M or S. S will just be the obverse of M. Okay, so all the numbers will just be upside down in the probability. So if it's a high probability for marriage, it's a low probability for singleness. There's only two states, and that's why it doesn't matter which one you pick. So I'm going to predict M for marriage, press run, and again, about 4,000. So we had about 18,000 originally, going, and that's the raw number, going down to 4,000 in the total number of options, and then it produces these three sheets. So let me start with the last sheet. The last sheet is a printable calculator, and the way it works is you look at your attribute, you look at your value, and then you determine, well, if it's 1911, I'm going to get this many points. If it's 1912, I'm going to get that many points, and all the way down the list. Okay, and then number of cars owned, and then other things. Then you total them up, and then the bottom here it says if it's at least 459, then it's married. If it's less than 459, it means other than married. So let me repeat what we're doing. We're predicting whether or not someone is married. We are not predicting whether or not someone will be married. It's not a future prediction. It's a current prediction. How might you use this? So if you had data, how many people have data, and this is just a rhetorical question, how many people have data that have demographic information that you know is messy or it's not clean? All right, so this is where this type of activity might be useful. So it might give you an indication of someone that might have made an error on a form or a mistake. So that's what the prediction calculator is. So now I need somebody to volunteer from the audience, and I'm going to have you pick values off of this form. So this one's the click down form. This one you actually pick values off of this form, and then it will score it off. So somebody raise your hand, and you are going to be my test person. Yes? Okay. So birth date year. 68. Number of cars owned. 2. House owner, yes or no? Yes. Occupation. Professional? Scientist. Okay, great. Gender? Male. Okay, education? Bachelor's. Yearly income. And this was American values. So for Europe, I don't know, I'd multiply by 2. That's how bad the dollar is. Sorry. Euros, though. Okay, so 60,000, there'll be 30,000 here on this chart. Okay, total children? 3. Number of children at home? 3. Okay, so you get different points. They have relatively different impact. The one on this chart, interpreting it, the one that had the most impact was that year, and then the yearly income and after that. This is a multivariate problem. So what it means is, given all these variables together, they all influence one another, and that total of 565 means that, according to this data, that person is probably married. Now, huh? You got the ring, okay. In fact, you're not the first person who's actually just picked the values just to reflect themselves, and they just wanted to see how it's going to come out. Now, one thing about this data, it does depend where this data comes from. This is the data for Contoso Retail. It doesn't reflect your friends. It doesn't reflect people that you know or anything else. If you do this type of exercise, all it does is it maps you to the values that are in this database. If the values in the database are bad, then the predictions will be just as bad. Okay, going to this other sheet. This sheet here, the prediction calculator report, this one is the one that shows or provides a value of that 459, where that 459 comes from. And what you do, I just went in with the defaults here. You get there's a false positive, a false negative, true positive, and a true negative. In this case, we were predicting marriage. So true positive is marriage. True positive is marriage. So this is the way I always think about these charts. You start with true and positive. False positive would mean identifying someone as married who was not married. Okay, so that's false positive. True negative is single. So you say someone is single and they actually are single. And then false negative then is the opposite. So that means saying somebody is single, but they're not single. And what this does allows you to tinker with the values here for how much it should cost to be off on the values. So I just was trying some different values here. So that one comes up with 459. This is 010, 010. That one also comes up with 459 because it's a mirror image. If I do 0, 0, 10, 10, that's also 459. If I do 40, 0, 10, 10, now this is a different number. Because there's a high number for judging someone is married who's not married, okay? Therefore, this number is going to be higher. The threshold you have to pass now is 701. So all it's saying is that depending on how accurate so this is an accuracy setting here. This is an accuracy setting for this prediction calculator. Depending on how important it is for you to detect someone married, you might be really conservative and go with like a high number, like 701. And if you were going to actually use this in an application, let's say some sort of application that would do some data cleaning, one idea you could have, so you could write this actually into your application, and wouldn't it be interesting to have this during the time someone's entering data on a screen to say that they're all these categories, or maybe they go through the entire list and then they give themselves values. And then maybe the application comes back and says, are you sure about certain values? Because maybe that value is unlikely compared to the database. And it's not forcing you to have that value. It's just saying maybe you made a mistake. Maybe you intended to put something else. And that's something you could do at the outset. Yes? Yeah. Right. So this is good. This is good for rapid data entry. I remember, when I was in college, I had a number of data entry jobs back in the day. I learned how to use a keypad really fast. And so this is a tool. So if you didn't have something like this, what would you have to do? You'd have to hard code your business rules. And even if you did hard code them, usually people only do it one column at a time, looking for outliers. So they're looking for, people claiming 10 million euro income, for example, per year, or something like that. So usually they're not done in a multivariate way. What we just did was multivariate. So it's based on the entire database. It's based on empirical data from the source, and also it is something that could be refreshed. You can have this model rebuild itself, say every week, every year, whatever frequency you think is appropriate, and also could filter. Doesn't have to be based. A model does not need to be based on the entire data set. I base on the entire one. You could also base one based on specific demographics and have different models. So you can see this can get very sophisticated pretty fast. So we did it for marriage. You also could do this for gender. You could do it for birth year. You could do it for yearly income. If you're a bank, if you're a financial institution, there may be some fields in here that are critical to you that they're correct. Not just because of the formatting or falling in a certain range, but also checking for that information. So that's pragmatically how to use this information. Another thing I want to say here is this combination, 1968, 2-1 professional. Now I'm not going to go look for it. Let's see if I can try to find it. 1968, let's try to find it. 1968, okay. Professional. Here are some of the other values. Male bachelors. Bachelors. Male. $30,000. So there's no 30,000. Okay. There's no 30,000 on the remaining set. The combination I did on the other screen is not on this page. And the point I want to make right now is data mining is more than just drill down. And I went to, there's a vendor, prominent vendor downstairs, and I'm not going to say their name, I'll tell you offline, that is marketing their controls as data mining controls. OLAP data mining controls. Data mining, as applied here, is giving us probability information on a combination that does not exist. In other words, I can't drill down into that original source data and give the combination that this gentleman gave me. It doesn't exist in the source data. So what it's doing is it's projecting a probability based on the other values. Based on the known values of all those fields for the entire set, it's still going to give you a result. So that's the difference between what is data mining and what is drill down. Drill down will only give you the exact empirical evidence there. Data mining can give you probabilistic information on the entire data set. In this case, we had categorical values, because even though birth date year is continuous, in this, as I applied it, I'm not doing 1968.1 to represent January or something like that. But if you were doing continuous variables, it would give you probabilistic information on the entire space. Not just the intersections, but the entire space. That's what the difference is between data mining and simple drill down. All right, now I'm going to go to answer that question about how many attributes. And let's see if my screen is still up here. All right, this is called happiness and number of attributes. This is going to answer the question about the number of attributes. And of course, earlier I was talking about 2 to the 31 minus 1 and 64,000 and these large numbers. And let's see if I can get my pencil out here without messing this diagram. So one thing that you could assume, perhaps, is that as you increase the number of attributes, that your happiness level would go up, right? So you put more attributes in, and you would just be happier and happier. So if we would just add more and more attributes, happiness just continues to improve. Or maybe you might think maybe happiness increases like, let's see, this one. Thank you. It wants to move that when I get close. All right, like that. So more like a parabolic thing. So the more you add, kind of all multiplies together. It's a multivariate model. But, there's two ways to look at the future. One is that maybe you might reach an asymptote. An asymptote means a point of no greater return. So it's be up there. So number of attributes increases, your happiness is like, then this statistical happiness would only go like that. Or what could happen is you actually could get dissatisfied and actually could go down as the number of attributes increases. So what are you going to do? One thing is to really know the data well. There are two approaches. As I'm going into this Contosa retail, I'm using all the variables because this was a well-designed data set. And you notice it was already clean. In actual reality, 80% of the time you spend in data mining is going to be data cleaning. I'm promising you right now. So if you started with nothing and you didn't have clean data, you still would have to go back and clean it. And you may even have to clean it for the data mining question that you have. So even if it's already clean, you still may have to do something. And I'm going to show that in a second. So we're going to have to move on to our next demo here. And that's for going back to this one. So we have our variables already there, and I'm going to add some sales variables. Now, the Fact Online Sales table has 12 million observations. So I'm going to do sales amount. Okay, so that'll be on the right. And I'm going to also do average sales. And what I decided, and just looking at this data when I was playing with it, average sales is a more interesting prediction. So I'm going to do prediction of average sales based on those demographic variables that I had on the left. So now this is summarizing all those 12 million observations. Now 12 million original Fact Online Sales table was a combination of company and people, but we're only going to do the people. I'm going to select the entire, let's see, wait. Yes, I'm going to select the entire pivot table. Copy. Go to the end. Paste. And format a table. And one thing I'll have to do here for the average sales amount, okay, now here's where I'm going to go to the data mining tab. And I am going to do, if I explored this data, well, I'm just going to go straight to I'll go to explore. Okay, so wait, go back. Rearrange as headers, yes. Okay, buckets. And that was just showing you the sales amount. Okay, press cancel. And I'm going to go to clean data, relabel, or outliers. So I'm going to go to first relabel. Average. Oops. Yeah, okay, no, that's good. Oh, no. Sorry, I meant to go explore data. Table, that's correct. Average, okay. This one will explore the data, and it's showing me here the average sales amount, the distribution, and I'm going to add that as a new column into the data set. I'm just going to go with what it has here as 8 buckets and then finish. And the reason I need that is for the predictions that I'm about to do right now. So I'm going to create a mining structure. A mining structure is a container for data, and I'm going to use all the values. I'm not going to use sum of sales amount. I'm going to use all the other values in this structure, and this is going to include everything. and go forward. And there's going to be a test data set that's automatically included there. Okay, I'm going to call it new structure. TechEd structure. Okay. Adding a model to TechEd structure, add decision trees, and I'm going to predict the average sales amount. Predict only. This one we're not going to use. And we're going to use everything else. Structure name trees. Decision tree, and there it was. Add model structure. And I'm going through this kind of fast because we're running at the end of our time here. So next one I'm going to pick is logistic regression. I'm going to predict average sales amount. Predict only. This one I'm not going to use. Next, finish. So there's a structure of variables. I'm adding models to that structure, multiple models. Again, I can have 2 to the 31 minus 1 models inside a structure. So there's also a lot of models that you can build within one structure. Third one here is naive Bayes. Do not use. This one we're going to predict that. Go forward. Bayes. Bam. Did it. This Bayes also, this will show you the strength of the links as I go up and down the scale. This thing I can browse later, but that shows the strengths of the relationships. And the final one I'm going to add is neural network. Next. And then I'm going to predict the same value. Predict only. Predict only. Don't use that one. Next. Finish. Neural nets. This one takes a little longer. Neural network is generally a more computation intensive algorithm compared to the other algorithms. But let's see finishing here. Task manager. Okay. Well, there was nothing to see. That's too. All right. So what I did is I had 4 models in there. If I do browse, I can see those 4 models in the TechEd structure and I made, and I can look at them later. This actually would be saved on the server because I did it from the data mining tab. And I'm going to select this structure, predicting average sales amount. Use a test structure. Finish. Okay, so what I just produced is called a lift chart. A lift chart gives us an idea of which model did the best in this case. That diagonal line is no model. So if you were just predicting it, and sometimes you get it right and sometimes you don't, that's what that diagonal line is. There's a top line here which is called the ideal model. The ideal model means you predict successfully every time until you've gotten all the predictions possible, and then there's nothing left to predict, so all the other ones are null choices. So that's why that's in that shape. So this is completely successful, and then the other ones vary in their success rate. And just looking at them, they're all very close. Okay, so I don't know. I think what you want to do is pick the one that came the highest here. The lowest one in this case was logistic regression. And then the second lowest one was a neural network for what I did. And then pretty much, I don't know, even are the other 2. So that would be decision trees and naive Bayes. About equal. Classification matrix. Okay, that will give us an idea of how successful these models were in predicting that value. And it'll use the test data. So it produces an output here. It shows how many predictions are right. This chart, to me, is the best way to do accuracy. And that is what it did is it automatically took a test sample data, and then it trained on a different set. So it took the test data, and then it shows how many times it succeeded and failed, just based on that prediction. So in this case, it colored the trees green because in this case, trees did the best in predicting those sales amounts. And then the last one here, which I'm not going to do, is cross-validation. Cross-validation is the simulation. And so what that allows you to do is run that same model, picking different samples inside the original data, and the default there is 10. And then based on that repetitive simulation, then it gives you the best model that did, based on those 10 runs. And then the purpose of that would be which model to put into production in some future data set would be based on, which one did the best with just random data presented during the trials here. So I encourage you to try different combinations. You can also experiment with the parameters for the data mining models. There's different ways to do the filtering. And then also, we didn't touch the sample button, but the sample button will also allow you to do oversampling. So if there's any cases in there that you want to include more than showing the source data, then that's what you would want to do. Oversampling is important for fraud detection, because fraud is usually a very rare case. So for that reason, you do want to do oversampling in that case. All right, I'm going to go back to my slides. Which I thought I did go back to the slides. Okay, I'm seeing it here. All right. Okay, so we had that data mining tab. I'm going to have you some resources. Okay, so here's how to get started. There's the Excel data mining add-in, which is free. PowerPivot add-in for Excel is free. Windows 7 and SQL Server 2012 is what I was using today, and then Microsoft Office. Does anyone here have kids who are in school, or maybe you're in school yourself taking a class? If you do, you can go to this website, dreamspark.com, and you can get free Microsoft software. And I think generally it will require you to have a .edu email address. But you can see the details on this website, dreamspark.com. You can get a copy of SQL Server, and so that's something that students might use or be able to use this technology in your projects. I think this technology, now again, I told you I supervise dissertations. I think this, if you had the right question, you would only need this technology to produce a dissertation. And I can make that claim because I actually teach in a school. But then you'll have to defend it, right? You'll have to say why your original research question is answered by this technology. But certainly, I think it's good enough for certain types of questions. So connecting with me, I have a landing web page there. I do have a data mining blog and data mining resources. I'm also on Twitter and LinkedIn, so definitely take advantage of that. I'll be giving out copies of my card if you want to connect with me later. Here's my conclusion. So SQL Server Analysis Services provides enterprise-level data mining to Excel with PowerPivot. I showed you the Analyze tab, the data mining tabs. We only got to skim the surface. I think this is a very deep topic. We wanted to keep it at level 200. I do want to show you on the other screen we have in our 1 minute. I guess what I do is press this button. No. Okay. There's 2 books I recommend. One is called Data Mining for Business Intelligence, and the other one's Data Mining with SQL Server 2008. And those are on my landing page I made for this presentation. So that's my landing web page, and I thank you all for attending. I also encourage you to fill out the evaluations, not just for this session, but all the sessions. I also appreciate very much any written feedback that you have for me, and feel free to come up after the presentation today if you have any questions. So thank you all for attending.